The suspension linkage is completely seized up with mud.
We'll note it. These tracks won't turn until she's stripped down.
This sector here doesn't make sense.
I agree. We need confirmation now, or we risk everything. The tolerances on this shaft are too wide. See that imperfection there?
I see it. Pull this crate for rework immediately. We need to check the blueprints again.
Keep moving! Faster!
Push forward, quickly now!
January 1940, United States. Snow presses flat against the factory roofs of Michigan. The air is quiet, too quiet for a world already at war. Across the Atlantic, steel is moving. German armored columns are rehearsing deep thrusts through Poland's frozen fields. British and French crews are digging in behind concrete and doctrine already aging. In Europe, tanks are no longer experiments. They are the spine of modern war. But in America, there's almost nothing. At Aberdeen Proving Ground, a handful of armored vehicles sit idle, thin-skinned, undergunned, built for parades and training manuals, not for blitzkrieg. The U.S. Army possesses fewer than 400 tanks, and none designed for sustained mechanized combat. Most are obsolete before they ever fire a shot. The nation that mastered the assembly line cannot yet build armored warfare. Inside War Department offices, maps are marked with question marks instead of arrows. Officers study reports from France and Poland with a growing sense of unease. If war comes, and now it seems inevitable, America will enter it blind, slow, and unarmored. The problem is no longer theoretical. It is mathematical. Time versus steel. And as the world tilts toward catastrophe, the answer will not come from a battlefield, but from a factory floor where the limits of American industry are about to be tested for the first time. The silence of January 1940 is about to collide with a war already in motion. The world moves faster than doctrine. By the time January 1940 arrives, the war has already rewritten the rules, just not for everyone. In September 1939, Germany invades Poland. The campaign lasts weeks, not months. Armored divisions punch through fixed defenses, bypass strongpoints, and collapse entire fronts before traditional armies can react. Tanks are no longer supporting infantry. Infantry is struggling to keep up with tanks. Military observers take notes. Some understand what they are seeing. Others explain it away. In the United States, the official interpretation is cautious to the point of paralysis. American doctrine still treats tanks as auxiliary tools, mobile machine gun platforms meant to assist foot soldiers. Independent armored warfare is viewed as reckless, unproven, even dangerous. The lessons of World War I linger like scar tissue. Mobility is mistrusted. Speed is feared. Control matters more than momentum. As a result, American armored development stagnates. Throughout the 1930s, U.S. tank design focuses on economy, simplicity, and domestic policing rather than continental war. The M1 combat car, built for the cavalry, is lightly armored and armed with machine guns. The M2 light tank follows, slightly improved but still thin-skinned, vulnerable, and tactically limited. None are built to survive direct engagement with enemy armor. None are designed for sustained operations under fire. By European standards, they are already relics. The German Panzer III and IV are entering service with radios, coordinated doctrine, and crews trained for rapid maneuver. The British, though doctrinally divided, are fielding cruiser and infantry tanks in large numbers. The Soviet Union is testing deep battle concepts and massed armor formations on a scale unmatched anywhere else. America watches but does not move. Part of the hesitation is political. The country is deeply isolationist. Congress resists military expansion. Budgets are constrained. Public opinion remains hostile to another European war. The U.S. Army ranks 17th in the world by manpower in 1939, behind nations like Portugal and Romania. Tanks are a low priority in a force designed primarily for hemispheric defense. Another barrier is institutional. Responsibility for tanks is split between the infantry and the cavalry, each with its own vision and procurement channels. The result is compromised machines that satisfy no one. Designs are approved slowly, tested conservatively, and produced in small batches that never mature into true weapons of war. When war breaks out in Europe, the United States possesses no heavy tanks, no standardized medium tank, and no industrial plan for mass armored production. Then, in May 1940, France collapses. In 6 weeks, the largest army in Europe disintegrates under the weight of German armored thrusts. Entire divisions are encircled. Communications fail. Counterattacks arrive too late or not at all. The Maginot Line, once considered impregnable, is rendered irrelevant. The shock is immediate and profound. American military attaches send frantic reports. The War Department pores over battlefield analyses. The speed of the German advance terrifies planners more than its brutality. This is not a war of attrition. It is a war of tempo. And tempo is exactly what the United States lacks. Emergency measures follow. In July 1940, the armored force is finally created as an independent branch under General Adna, R. Chaffee Jr., consolidating tank development and doctrine for the first time. It is a tacit admission that previous assumptions were wrong. But acknowledgement does not equal readiness. Even now, America has no tanks suited for modern combat in large numbers. The M2 medium tank exists only in limited prototypes. Its armor is thin. Its main gun is mounted in a sponson, restricting traverse. It is a design already behind the curve before production even begins. The clock is running. Factories that could build tanks are producing automobiles, tractors, refrigerators. The government arsenals, Rock Island, Watervliet, are skilled but slow, accustomed to peacetime pacing. They cannot suddenly produce thousands of armored vehicles without years of expansion, and the war will not wait. By late 1940, it becomes clear that the challenge is no longer just military. It is industrial. The United States must leap from near-zero armored capability to mass production in record time. Not incrementally, immediately. Because if America enters the war with the army it has, it will lose the war it is heading toward. And somewhere between doctrine and desperation, a new question begins to form. One that shifts the problem from generals to manufacturers. If the Army cannot build tanks fast enough, who in America can? When war becomes an industrial equation. By the autumn of 1940, the United States no longer debates whether it will need tanks. The argument is now about how many and how fast. President Franklin D. Roosevelt understands this before most. In December 1940, he speaks not as a commander, but as an industrial realist. America, he declares, must become the arsenal of democracy. The phrase is not rhetoric. It is a production order disguised as philosophy. Behind closed doors, the numbers are brutal. European battlefields are consuming armored vehicles at rates never seen before. Dozens lost in a single day. Hundreds in a campaign. Any future American tank must be replaceable, not in months, but in weeks. It must be reparable in the field. It must be shippable across oceans. And above all, it must be buildable by the tens of thousands. The U.S. Army Ordnance Department, responsible for weapons design and procurement, is unprepared for this scale. Its facilities are precise but rigid. They excel at craftsmanship, not velocity. Arsenal-built weapons are reliable, but slow, expensive, and unsuited to the tempo of modern war. The solution cannot come from within the Army alone. So the War Department looks outward towards civilian industry. This is not without resistance. Many industrial leaders have never built weapons. Fewer still have worked with armor plate, gun mounts, or combat tolerances. Tank production is dirty, complex, and unforgiving. Steel thickness must be exact. Welding must survive blast and vibration. Tolerances are measured not in comfort, but in survival. Yet civilian industry has something the Army lacks: systems thinking. Automobile manufacturers understand flow. They understand supply chains, standardization, and bottleneck elimination. They know how to design a product so it can be built by thousands of workers, many of them unskilled, without sacrificing reliability. And among them all, one name dominates the conversation: Ford. Henry Ford's company is already synonymous with mass production. The moving assembly line has reshaped American life. Ford plants operate at a scale no government arsenal can approach. The company controls steel supply, machining, transport, and workforce training under one corporate structure. But there is tension. Henry Ford himself is a controversial figure, politically isolationist, openly skeptical of war, and deeply resistant to military contracts. His views complicate negotiations, yet the company's technical leadership understands the stakes. Edsel Ford, the company's president, is more pragmatic. He recognizes that if war comes, industrial refusal will not stop it, only shape how prepared the nation is when it arrives. In parallel, tank design is undergoing its own crisis. The Army rushes an interim solution into production, the M3 Lee. It is a compromise born of urgency. A 75mm gun mounted in a hull sponson. A smaller turret on top with a 37mm gun. Tall, awkward, and doctrinally outdated, but crucially buildable now. The M3 is never meant to be permanent. It is a bridge. While it rolls into production in 1941, engineers are already drafting its successor. A true medium tank. A rotating turret with a 75mm gun. Better armor distribution. A lower profile. A machine designed not for perfection, but for repeatability. This future tank will become the M4 Sherman. From the beginning, the Sherman is shaped as much by factory constraints as by battlefield theory. Armor plates are sized to match existing presses. Engines are adapted from aircraft and automotive designs. Components are standardized so multiple manufacturers can build identical parts in parallel. This is a radical shift in military thinking. The tank is no longer treated as a handcrafted weapon. It is treated as an industrial product optimized for scale. Engineers accept trade-offs consciously. Thinner armor in exchange for speed, mechanical reliability over experimental firepower, ease of maintenance over bespoke excellence. And this is where Ford's role becomes decisive. The government does not ask Ford to design Sherman. It asks Ford to redefine how tanks are built, to apply automobile logic to armored warfare, to compress years of production learning into months. By early 1941, contracts are signed. Facilities are surveyed. New plants are planned with war in mind from the first blueprint. Production lines are sketched not around craftsmen, but around flow rates. The gamble is immense. If this system works, America will drown the battlefield in steel. If it fails, the Army will arrive late to a mechanized war already lost. As blueprints harden into factory layouts, and workers begin training for machines they have never seen, the question is no longer whether the Sherman will fight. It is whether quantity itself can become a weapon. And that question will soon be answered from angles far beyond the factory floor. For ways to understand one machine, the M4 Sherman is often judged as a single object: steel, rivets, armor thickness, gun caliber. But in 1941, it is not one thing. It is many, depending on where you stand. Inside newly converted factories, civilians become armor workers almost overnight. Auto assemblers, tool and die specialists, farmhands. Many have never seen a tank before they are asked to build one. Training is compressed. Mistakes are costly. A misaligned weld can mean a split seam under fire. A faulty casting can cost a crew their lives months later on a different continent. Women enter the workforce in numbers previously unthinkable. Riveters, inspectors, machinists. Their work is not symbolic. It is structural. The Sherman's reliability will rest on hands that have never worn a uniform. The pace is relentless. Shifts blur together. Production targets climb monthly. The pressure is not abstract. Every delay is measured against casualty estimates arriving from Europe. The Sherman is not designed to dominate enemy tanks in isolation. It is designed to function as part of system. Its 75mm gun is selected not for armor-piercing supremacy, but for versatility, high explosive fire against infantry, fortifications, and soft targets. Its armor is sloped intelligently, not thickened excessively. Its suspension prioritizes durability over experimental innovation. Most importantly, the Sherman is engineered to be repaired. Engines can be swapped, tracks replaced, components standardized. A disabled tank is not written off. It is recycled back into combat. This is not accidental. It is philosophy. Men like General George C. Marshall and General Brehon Somerville understand that the war will not be won by rare masterpieces. They demand weapons that can be produced faster than they are destroyed. Their influence pushes design committees toward decisions that offend purists but satisfy logisticians. Speed matters more than elegance. Numbers more than novelty. American armored doctrine evolves under pressure. Tanks are not expected to duel enemy armor head-on. That role is increasingly assigned to tank destroyers and artillery. Shermans are meant to exploit breakthroughs, support infantry, and maintain momentum. Critics will later call this naive. In 1941, it is pragmatic, because behind every angle, human, technological, leadership, doctrinal, lies the same constraint. The war will be decided not by what is theoretically possible, but by what can be built, shipped, maintained, and replaced at scale. And as these ideas harden into production lines and training manuals, the Sherman begins to move from concept into motion, its meaning shaped as much by enemies watching from across the Atlantic as by Americans building at home. How the enemy sees you, and what that does to a war. German intelligence does not dismiss the Sherman. It misunderstands it. Early battlefield encounters in North Africa reveal a tank that is mechanically reliable, fast to repair, and, most unsettling, never alone. Where one is destroyed, another appears. Then another. Crews begin reporting a pattern that has little to do with armor thickness and everything to do with volume. German tank doctrine prizes technical superiority. The Panzer IV evolves into heavier variants. The Panther and Tiger follow, formidable, lethal, and expensive. Each is designed to win the duel in front of it. The Sherman is designed to ensure there is always another duel. This asymmetry creates psychological pressure. German commanders note that American armored units absorb losses without losing momentum. Supply lines refill gaps with unnerving speed. Tanks arrive clean, fueled, standardized. Often faster than damaged German vehicles can be recovered or repaired. The battlefield begins to feel unbalanced, not tactically, but industrially. The Sherman forces a question that has no clean answer. Is it ethical to send crews into combat in a tank known to be outgunned by later German designs? Critics will later argue that American leadership chose production quotas over protection, that lives were traded for speed. But in 1942 and 1943, the alternative is stark. A perfect tank delivered too late saves no one. A good enough tank delivered in time may save a war. American planners do not ignore the risk. Upgrades are constant. Armor is thickened where possible. Firepower improves. Variants emerge. But no change is allowed to disrupt production flow for long. The line must move. The morality here is industrial, not personal. Decisions are made in boardrooms and offices far from the front. Yet their consequences are intimate, measured in burned hulls and surviving crews, in men who climb out alive because the engine started or die because it did not. The Sherman becomes a mirror of democratic warfare. It is not invincible. It is accountable to voters, to budgets, to timelines. Its flaws are debated openly. Its successes are counted in tonnage, shipping manifests, and replacement rates. By late 1942, the equation is clear. The Sherman is not meant to be remembered as the best tank of the war. It is meant to be the tank that shows up again and again until the enemy cannot. And as that realization spreads from intelligence reports to battlefield experience, the war reaches a point where theory ends and proof begins. Because the moment is coming when the Sherman will no longer be judged on paper or in factories, but under fire, at scale, where production numbers meet enemy steel. When production becomes a weapon. By mid-1942, the M4 Sherman is no longer an idea. It is a current. Across the United States, tank production accelerates beyond anything the Army once believed possible. Factories in Michigan, Ohio, Illinois, and California operate around the clock. Components arrive pre-timed. Cast hulls slide into welding bays. Engines, radial aircraft types adapted for armor, are lowered into place with practice speed. Each station is measured, each delay analyzed. The tank is treated not as a singular machine, but as a unit in a flow. Ford's influence is unmistakable. Though the company does not build every Sherman, its methods reshape all of them. Process control replaces artisanal judgment. Parts are interchangeable across manufacturers. Quality is enforced statistically, not individually. If a flaw appears, the line is adjusted, never stopped unless absolutely necessary. By the end of 1942, American factories are producing thousands of medium tanks. The numbers outpace Axis expectations and Allied skepticism alike. More importantly, production is predictable. Commanders can plan offensives, knowing replacements will arrive. The proving ground is no longer Michigan. It is North Africa. In November 1942, Allied forces land in Morocco and Algeria during Operation Torch. For the first time, large numbers of American tanks enter combat against German forces. The results are uneven and brutally educational. At battles like Kasserine Pass, Shermans face seasoned panzer units. German anti-tank guns punch through frontal armor. Tactical coordination falters. American crews, inexperienced and undertrained, suffer losses. Critics later point to these moments as evidence of Sherman inferiority. But the battlefield tells a more complex story. Damaged Shermans are recovered, repaired, and returned to service in days, not weeks. Units absorb losses and continue fighting. Where German tanks must be husbanded, American commanders commit freely, knowing more are coming. By early 1943, lessons are absorbed with remarkable speed. Tactics improve. Combined arms coordination tightens. Shermans begin operating with infantry, artillery, and air support in integrated formations. The tank's limitations are acknowledged and worked around. And while individual engagements remain costly, something irreversible is happening beneath the surface. The replacement curve tilts. For every Sherman knocked out, another is already unloading at a port. For every tactical setback, the operational tempo continues forward. German commanders begin to report not just resistance, but exhaustion. They are fighting not just enemy units, but a pipeline that never seems to slow. By the spring of 1943, it is no longer possible to separate the Sherman from the system that sustains it. The tank is not winning battles alone, but it is enabling a style of warfare the Axis cannot match, one where loss does not equal collapse. And as Allied forces prepare to push beyond Africa into Europe itself, The question facing Germany is no longer whether the Sherman can be destroyed. It is whether it can ever truly be stopped. Steel that keeps coming. By 1944, the nature of the war in Europe has changed. The question is no longer whether the Allies can land on the continent. It is whether the continent can absorb what is coming. On June 6, 1944, Allied forces crossed the English Channel. Alongside infantry and airborne units, the Sherman arrives in force, modified, waterproofed, and adapted for the invasion. Duplex drive variants swim ashore. Bulldozer Shermans clear obstacles. Flamethrower versions wait offshore. The tank has become modular, its form adjusted to mission without breaking the production chain behind it. In Normandy's hedgerows, the Sherman suffers. Closed terrain negates maneuver. German Panthers and Tigers exploit range and firepower. Losses are real, visible, and often catastrophic at the crew level. But the flow does not stop. American depots replace destroyed vehicles faster than German units can replace crews. Recovery teams salvage hulls under fire. Field modifications spread laterally through units. Improvised armor, track links welded to hulls, new tactics shared through after-action reports. By August 1944, breakout operations begin. Mobility returns. And here, the Sherman's original design logic comes into full effect. The tank moves, and keeps moving. Engines start reliably. Transmissions hold. Tracks endure long marches. Supply columns follow closely, feeding fuel and ammunition at a rate the German army can no longer sustain. Panthers are abandoned for lack of parts. Tigers are destroyed by their own crews when recovery is impossible. The dual myth collapses. War is revealed as a system of endurance. From France to the German border, Sherman's spearhead advances not because they are superior in isolation, but because they exist in overwhelming continuity. They arrive in daylight. They return after losses. They operate in coordination with air power that now dominates the sky. By the time Allied forces cross the Rhine in 1945, the industrial outcome is settled. Germany still fields formidable machines, but in numbers too small, too fragile, too late. The Sherman does not end the war by itself, but it ensures the war cannot be stopped once momentum turns. And when the shooting finally slows and factories begin to wind down, the scale of what has happened becomes clear. A nation that had no modern tanks in 1940 has built tens of thousands in less than 5 years, enough to fight across 2 oceans, supply allies, and replace losses continuously. The decisive moment was not a single battle. It was the point at which production outpaced destruction. And that moment, once reached, could never be reversed. The war now moves into its consequences, measured not just in victory, but in cost, memory, and judgment. What victory cost and what it required. When the guns begin to fall silent in Europe in the spring of 1945, the M4 Sherman is everywhere and nowhere at once. It lines roads outside ruined German towns, engines ticking as crews wait for orders that will never come. It sits burned out in fields where battles ended months earlier, its hulls already rusting into the landscape. It moves east in convoys, west toward ports, south toward depots. A machine built for war now has no single place to belong. By the end of the conflict, the United States and its allies have produced nearly 50,000 Shermans, a figure unprecedented for a medium tank. No German design comes close. No British or Soviet counterpart matches its global distribution. The Sherman fights in North Africa, Italy, France, Germany, the Pacific, and China. It serves with American, British, Canadian, Free French, Polish, and Soviet units, sometimes simultaneously, often interchangeably. This alone reshapes the meaning of armored warfare. Losses, however, are inseparable from this scale. Thousands of Shermans are destroyed in combat. Crews are killed, wounded, burned. Survivors later speak not in terms of engineering diagrams, but in moments, hatches jammed, ammunition cooking off, engines that either save or doom them in seconds. These accounts fuel post-war criticism, much of it severe. The Sherman's armor, particularly on early models, proves vulnerable to high-velocity German guns. The tank's height makes concealment difficult. Its gasoline engine increases fire risk under penetration. These are not exaggerations. They are documented realities. Yet context matters. German tanks achieve high kill ratios in certain engagements, but they do so in battles they ultimately lose. Tactical superiority does not translate into strategic survival. German industry cannot replace losses at the same rate. Factories are bombed. Transport collapses. Fuel shortages immobilize surviving armor. American losses, by contrast, are absorbed into a system designed for replacement. Damaged tanks are recovered. Crews are rotated. New units arrive already trained on standardized equipment. The Army does not pretend this is painless. It simply accepts that war on this scale cannot be otherwise. Official reports after the war reflect this tension. Some praise the Sherman's reliability and ease of maintenance. Others criticize its survivability against late-war German armor. Both are correct. The tank is neither miracle nor mistake. It is a solution to a specific problem built under extreme constraint. In the Pacific, the Sherman's reputation shifts again. Against Japanese armor, lighter, fewer, and less well-coordinated, the tank performs decisively. Its high explosive firepower proves invaluable against fortified positions. Flamethrower variants reduce casualties in assaults that would otherwise cost hundreds of infantry lives. Here, the Sherman is not merely adequate. It is dominant. These contrasting theaters complicate any single judgment. What emerges instead is a broader conclusion. The Sherman works best when war itself is treated as a system. When logistics, air power, infantry, and artillery are integrated. When replacement is planned, not improvised. When industrial depth supports battlefield risk. This understanding reshapes post-war military thinking. American planners study not just the tank, but the conditions that made it effective. They note that even a technically superior enemy vehicle becomes irrelevant if it cannot be supplied, repaired, or replaced. They conclude that future armor must balance protection, firepower, and mobility, but never at the expense of production feasibility. The Ford-led production model becomes a case study taught for decades. The United States does not celebrate the Sherman as an icon in the way Germany mythologizes the Tiger or Panther. Instead, it becomes something quieter, more unsettling, a reminder that modern war is decided long before the first shot is fired in design meetings and factory layouts. For the men who fought in Shermans, the legacy is personal. Many remember the tank as a cramped, dangerous space that nonetheless carried them through battles they might not have survived on foot. Others remember friends who did not make it out. Their memories resist simple conclusions, and that resistance is fitting, because the Sherman was never meant to be loved. It was meant to be used. And as the world takes stock of what has been won and lost, one final reckoning remains: how this machine, and the system behind it, permanently changed the way nations prepare for war. That question leads forward beyond the battlefield, into the long shadow of peace and the doctrines it will reshape. The shape of war after the fact. When a factory's finally slow, the silence feels unnatural. In Detroit, Lima, and Chicago, production lines that once ran without pause are dismantled or repurposed. Jigs designed for hulls are scrapped. Casting molds are cooled and stored. The tempo that defined 4 years of total war disappears almost overnight. Yet what remains is not simply surplus steel. It is a transformed understanding of how wars will be fought from this point forward. The Sherman leaves behind more than numbers. It leaves behind a doctrine of industrial inevitability. Post-war U.S. Army studies do not frame victory in terms of individual weapon dominance. Instead, they focus on sustainment. Reports emphasize that American armored units maintained operational momentum even after heavy losses because replacements arrived on schedule. Crews were retrained on familiar equipment, and logistics remained intact under pressure. The tank becomes an example of a system functioning as intended. This lesson reshapes the Cold War military. Future American tank designs, patent series, and eventually the Abrams will still chase technical superiority, but never again at the expense of manufacturability. Modularity, standardized parts, and supply chain resilience become permanent requirements. Engineers remember the Sherman not for its armor thickness, but for its ability to exist everywhere at once. The influence extends beyond armor. Aircraft, ships, missiles, even space programs adopt the same logic. Redundancy is embraced. Production scalability becomes strategic doctrine. The belief takes hold that wars between industrial powers will be decided less by a singular brilliance and more by sustained output under pressure. Ford's role in this transformation is studied with particular care. The company proves that civilian industry can be adapted to total war without losing efficiency. Its methods demonstrate that speed and quality are not opposites when systems are designed correctly. This realization permanently alters the relationship between government and private manufacturing. Defense contracting becomes a peacetime institution, not a wartime improvisation. But there is unease beneath the success. The Sherman story forces a confrontation with uncomfortable truths. Industrial warfare reduces human experience to variables: replacement rates, output curves, tonnage shipped. Individual suffering risks being obscured by aggregate success. Critics argue that this logic, once normalized, makes future wars easier to enter and harder to limit. Veterans' accounts complicate the picture further. Some describe the Sherman as dependable, forgiving, even protective when properly handled. Others remember it as a thin barrier between life and fire. These memories coexist without resolution. History does not choose one. By the early 1950s, Shermans still serve in conflicts from Korea to the Middle East long after newer designs exist. Their continued use speaks not to technological superiority, but to availability. They are there. They work. They can be kept running. Eventually, they fade from frontline service. Museums absorb them. Monuments freeze them in time. Photographs flatten their meaning into still images of steel and dust. Yet their real legacy is invisible. It lives in procurement manuals, in factory layouts, in the assumption that any future war between major powers will be fought not just by armies, but by entire economies. That assumption, born in the urgency of 1940, becomes one of the defining principles of modern conflict. The United States did not enter the Second World War with tanks ready. It entered with factories capable of learning faster than the enemy could adapt. The Sherman was the proof. And as the 20th century moves forward, carrying this lesson into ever more complex forms of warfare, the final question is not whether the Sherman was the best tank of the war. It is whether the world that built it can ever afford to forget what it revealed about itself. The Sherman's quiet lesson. The M4 Sherman is rarely remembered for elegance. It was not the heaviest, the fastest, or the most powerful tank on the battlefield. Yet its significance lies in a quieter, more profound truth. It proved that war could be waged as much by factories as by armies. In 1940, the United States had almost no tanks. By 1945, it had tens of thousands scattered across continents, fighting continuously and sustaining momentum where the enemy could not. The Sherman was the embodiment of a new logic. Speed, reliability, and replaceability could outweigh singular technical brilliance. In this way, it became more than a weapon. it became a symbol of industrial warfare. The men who rode inside its armored hulls experienced war intimately. Some survived by inches, others did not. Yet the machines themselves survived not because of individual perfection, but because of a system designed to ensure they would always be there. The tank's flaws were real, its dangers clear, but so too was its function, and that function changed the calculus of battle. For history, the Sherman teaches a lesson about priorities. In modern conflict, numbers, logistics, and adaptability can define victory as decisively as firepower. For humanity, it is a reminder of the cost of industrial efficiency, that lives, bravery, and ingenuity are entwined with spreadsheets, blueprints, and assembly lines. And in this truth lies its quiet power. The Sherman did not dominate because it was invincible. It dominated because it never stopped arriving. Its legacy is not only in tanks or victories, but in the understanding that in total war, survival depends as much on production as on courage, and that the measure of a nation's strength can be found in the hum of its factories as clearly as in the roar of its guns. The world learned, painfully and irreversibly, that war could be won not by singular genius, but by systems designed to endure. The M4 Sherman was the first and most visible proof of that truth.